Hey, good afternoon, everyone. How's
Good
everybody?
afternoon.
Hi, good afternoon, Tia. Hey, I see 7 people, and quickly checking uh, forum. I see how many people. There are 8 people, so one person still needs to join. And I guess this person is joining right now. All right, so well, the midterm is over, and some people may be happy about it. Some people may not be happy about it. But uh, I believe all of you gave your best shot. We have to always give our best shot under the constraints that are given to us, and we have to. It's a given in life that we have to. Uh, we face constraints, and we want to maximize, the fruit of our efforts under the given constraints, and that's the same thing. I mean, you might be. Uh, you might think, some people got something like 60 something, and those people get, those people might panic. uh, isn't This is fail, this is enough, I'm failing. No, no, no. Again, in my grading system, uh, there is no given score rubric like, 60s fail, 70s D. No, nothing like that, right? It all depends on where the mean is, and what is the standard deviation based on the, mean and the standard deviation. Of course, if you are below mean, that's not a good news, right? And if you're above mean, that's relatively a good news. But depending on how far away you are above the mean, right? Because mean is what an average person with an average intelligence would attain. That's what, is meant by mean, right? Um, and if you're dealing with a random, uh, if you're dealing with a random uh, sample, that means, randomly selected uh, people. The mean average of the intelligence of the people and the effort of the average person in this random sample. Uh, that is what someone with, uh, uh, that person, an average person with average intelligence and average effort, uh, will exactly norm to the mean of the results. And also, this will work regardless of how difficult the exam is or how easy the exam is. Uh, if the exam is written very hard, I mean, if the exam is made very hard, the mean will be very low anyway. Mean will be something like 40. If the exam is very easy, the mean is somewhere around, 80. And then, 80 is, then think about it. If the mean is 90, 90 is not a wonderful achievement. It's just what an average person with average intelligence and average effort will attain, right? So, just because you got 90, you cannot be complacent that, oh, this must be at least A minus. No, there's no way you can get A minus if you're just mean. Mean is just an average, right? And an average will get the mean grade. Yeah, and what's the mean grade? A median grade rather. Median grade. What's an average will get a median grade, and the median grade is B minus, right? So anyway, I'm not gonna. This will be this will take up our time, so I'm not gonna go over that again. I expressed this already, on several occasions. Also, when we get to the risk and return, part one, this will you will have you will learn more about this, so that it will become more clear at the time. Now, so I just want to go back to our okay. Let me. So last Thursday was right our last class, and last Thursday we basically finished everything about the future value of annuities. So next we need to move on to the present value of annuities. And the present value of annuities, so did I download that file? Time value, compounding or time value? Let's see. Oh, how come I didn't? Oh, lecture notes. I gotta go into the lecture notes. Time value there, it's already open. Compounding. So, what is present value of annuity then? Well, then, it's the, literally, annuities are all in the future, right? Annuity payments are all in the future. I mean, whatever has happened, what's in the past, is totally irrelevant to us, because the valuation, there is no need for any valuation for something that happened already in the past, right? All the financial assets are bearing fruit in the future, right? So our annuities are always in the future. I mean, in case of future value of annuities, they are all these annuity payments are in the future. And question is, what is the total of all of them at the end of our maturity, right? And in present value of annuities, you have annuity payments, cash flows in the future, and what's the present value of that at time zero? That's the question. So when do we have these, when are the occasions when we use present value of annuities? I'll give you two examples. First example, which is unrealistic, but this is pedagogically easy. Pedagogically easy. I mean, in terms of for illustrative purpose, there's nothing easier than this. Suppose you won the lottery, and the jackpot is $10 million. And usually when you play lottery, and you have two payout options. One is either one is receiving the lump sum payout, and the other one is annuity payout. Annuity. Now the lump sum payout, if you choose lump sum, you will receive about 60% of the jackpot amounts, Why 60%? Because you have to pay taxes, right? And the tax rate is actually 39%. So it doesn't matter what tax bracket you are, what's your top tax bracket. It doesn't matter. I mean, it doesn't depend on your actual taxable income, but it basically lottery prize money, lottery winning is a windfall gain, right? It's not something you earned, right? It's not something you worked hard to earn. It's not earned income. It's a windfall gain. And for windfall gain, regardless of your top tax rate, they apply, regardless of what is your actual top tax rate. Your top tax rate may be 28%. Doesn't matter, right? It doesn't matter. The actual, the top tax rate in the tax bracket, right, which is 39%, will be applied. 39% will be applied. So it's 39%. So I'm roughly approximating it as 40%. Okay. So if it is 40%, out of 10 million, yeah, 6 million, that's after tax, right? And so let me open the where is my whiteboard? Okay, whiteboard is easier to. Oh, and I also brought my. Where is my? I brought my touch pen or stylus. So. Okay, it's taking forever. So, so think about it. If you take lump sum, then it's 6 million. If you choose annuities, you will receive about $20,000 every month for the next, 30 years. Okay, it's actually 29 years. I recovered my password, so let's see. Let's see if it's going to work. There you go, yeah. All right. So, if jackpot is 10 million, right? Lump sum, you'll take about 6 million. And then annuities, if you choose annuities, it will be about 20K a month. And then since it is 30 years, actually it is 29 years, right? I checked the what do they call that? Game and hunting and game or whatever, but the lottery authority, right? It's 29 years, but it's roughly 30 years. So let's say that's going to be 360 months, right? So the question is, then do I pick this one? Do I choose lump sum or do I choose annuities? Some people might say, I'll choose lump sum because I don't know if I'll still be alive, if I'll still be around in 30 years for the next 30 years. Look, we are basing it on, average life expectancy of an average, a person in the U.S. Average life expectancy these days would be around, 80 something, 82 for women, or maybe more for women, at least something like 81, 82 for men. And if you are only about 20 something, yeah, you have, more than 20 years to live, unless you are 60 something. If you're 60 something and if you won the lottery, you may, based on the average life expectancy, maybe you won't be able to enjoy it for, the 30 years. You may have only about 20 years left. Maybe then you would choose lump sum. But if you are 20 something, it's, most likely you will live, right, more than 30 years. Unless you are leading a very reckless lifestyle, right? So think about it. Then the question is, some people might think, okay, if I live more than 30 years, then what's this going to be? You might think, oh, that's going to be 7.2 million. Simply, why? Because it's 20K a month times 360. Then, you might think, oh, this 7.2 million is greater than 6 million, so I'll choose this. Well, that's not right either. Why? Because first of all, this dollar amount, this doesn't exist at any single point in time, right? There's no 7.2 million either at time zero or at 30 years later, right? What you did was you simply multiply this 20K per month for 360 months. But then again, that simple aggregation, the result of that simple multiplication or aggregation of these 360 payments of 20K, it doesn't exist at a single point in time. So you cannot make this 7.2 million aggregation, right? What actually exists is basically, from time zero, right? From time zero until end of month 360, there are only, these 20Ks spread out over 360 months, right? So we all know, if we were to compare the 6 million, we cannot compare that with 7.2 million, but we have to compare it with the present value of all these annuities, right? Present value of all these annuities, right? We'll have to compare it with the present value of all. And as shown in this simplified version, what we need to do is, this is really, a simplified version because the reality cannot be like that. In other words, suppose you're receiving $5,000 at the end of every month for the next 5 years. I mean, at the end of every year for the next 5 years. All you need to do is discount the first 5,000, right, to present, to time zero. And if the discount rate is 10%, right, that's what you do. And then second 5,000, discount it twice. Third, right? And we can find, present values of each of these annuities, right? And find the sum of all of that. And then again, we know the reality isn't this simple. I mean, there are only 5 payments in this example, but In our example, there are 360 of them. 360 of them. You have to find the present value of this, present value of this, present value of this, present value of this. I mean, you have to do this for 360 of them, which is not undoable. It's not undoable, but it's just simply too tedious, right? It's not impossible. It's too tedious. So then what do you need to do? Well, of course, we need a reduced form formula, right? So the reduced form formula is, so basically, the idea is, what happened? Okay. We know present value of all those annuities are basically sum of all these payments discounted by 1 plus r raised to n, where n runs from 1 through 1 to t. Okay? Remember, future value of annuity, I mean, this is just an expression. This is not the formula, right? This is simply a way of condensing all of these. First 20K will be, in other words, this is, first 20K right, discounted once, plus second 20K discounted twice, plus all the way, right, to the last 20K. Come on. Right? Last 20K discounted all the way back to present, right? But, since we cannot do this, right? Since we cannot write out, right? Since we cannot write it out, I mean, it's a tedious job to, you have to do 360 terms of this. This is a long polynomial, very long. Very long polynomial. You can't really, it's not undoable, but, it's a very tedious thing. So since we don't want to do this, that's why we use this, right? That's why we use, But then again, that's not a formula. But actually the formula is, the formula, we come to the formula of, this thing turns into a payment over R minus payment over R times 1 plus R raised to N. Okay, this is the formula. This is the formula. Okay, and you might remember also from future value of annuities, right? In future value of annuities, what was the formula? I mean, future value, you already know the future value of annuity formula, right? Which is, I'm going to write it. payment times 1 plus r raised to n minus 1 over r, right? That's the future value of annuity. But future value of annuity was also, before arriving at this reduced form, formula, it's basically payment times 1 plus r raised to n, where n runs from 1 actually n runs from 0 to t minus 1. Okay, why? Because so I think you should understand why, because on the timeline, right, if we have time 0 to time 60, I mean, this is 60th month, right? The first deposit, right, first deposit of 800 will what's going on? First deposit of 800 will earn interest 59 times, right? Because you're starting from here. And the last deposit, right? And the last deposit earns what's going on? And the last deposit earns, the deposit made at this point, right? It earns no interest, which is, basically 1 plus r raised to 0, right? So that 0 is this 0, right? And 59, that's t minus 1, right? And then here, so by the same token, right? So if we use this formula, by using that formula, right, we can solve this. We can solve this problem. And then, what's the point? The point is, if you shouldn't lose the perspective. The perspective is, what are we trying to do? We are trying to compare if receiving 6 million lump sum is better or receiving annuity is better. But since 6 million is already this is already present value, right? Because you're receiving it at time 0. But if you are receiving annuities, because all those 20Ks, all those annuities are spread over the next 360 months, you cannot make a direct comparison, right? You cannot make a direct comparison like this. So the only way we can make that comparison is to find the present value of all those annuities and compare it, whether it is greater than or less than, right? If present value of annuities are greater than or less than the 6 million, whichever is greater, that's your choice, right? That's what you need. That's what you need to. That's what you pick, right? That's your conclusion. So That's the first example. The second example is this is more this is closer to life, because I already told you that in reality, if you borrow money, right? If you borrow $1 million, no lender waits. Let's say you borrowed $1 million for 30 years at 10% interest rate or 6% interest rate, whatever. No one waits. No lender waits 10 years, or did I say 30 years? Whatever. Um, no lender waits 30 years for you to come up with the full future value, right? So in reality, um, you cannot expect any lender. You cannot expect to borrow money thinking that all I need to pay back is this future value in 10 years. No, it's not. It's not going to work like that. You will have to. Uh, you will need to. The reality is that they want you to start making payment, partial payments, right? And in a monthly installments. So it will be an annuity, right? If you borrowed money, the payment starts already next month, um, in monthly installments. So if you borrowed it for 10 years, then uh, the the payment there will be 120 payments, right? Monthly payments. That's going to happen over the next 10 years, right? So it's an annuity, right? So, and borrowing is a very common thing. It may not be very common as, not everyday. It's not an everyday thing, but in your life, you will need to. There will be at least 4 occasions that you will need to borrow money, right? 4 occasions, 2 to 4 at least. Why? First, uh, when you buy a car, right? If you buy a car, uh, if you even if you have money, and let's say you're buying a $30,000 car, you may already have $30,000, but it might be a it might be a better option. It might be a wise wiser choice to finance it, right? Um, or if you don't have 30K, I mean, even if you have 30K in cash, it's a smarter thing to not to just spend that 30K on the car, but rather finance, right? Because you never know what kind of a lucrative investment opportunity might arise even next month. And if you have already spent $30,000 on the car, there is no way you can. And this investment opportunity uh, has average return of 20%, right? Average annualized return of 20%. Um, then whereas if you finance, right, if you borrow money to pay for this car, then the interest rate on it may be only about 5%. And in that case, using um, the $30,000 that you didn't spend for the car, but invested in this, asset that pays you 20% a year, is definitely a superior option, because if you borrow, it's only 5%. You pay 5% for interest, but you borrow 30K, and but by investing the 30K that you had, uh, it will give you 20% return. So that return, 20% return, already pays for that 5% and still leaves you 15%, right? So that's why even if you have 30K on hand, you don't use it to buy the car, but rather you finance it, right? And Otherwise, you don't have 30K, so you need to finance it. I mean, if you don't have, right, uh, lump sum 30K, you need to finance it. That's the first occasion. Second, when buying a house, there's no way you can afford to pay $1 million for the house, right, out of your pocket. So you have to get a mortgage, right? Mortgage is, a mortgage loan. Basically, you borrow $1 million. So there are at least, and then what's the third occasion? Third occasion is, a student loan. You may or may not need a student loan, but if you get a student loan, right? Um, and the fourth occasion is if you start up a business. If you start up a business, again, it's gonna be a very difficult thing to borrow money for your business as a initial startup capital. I've been explaining why, but if you can borrow, I mean, even through, your luck, if even you can be lucky to get, small business, SBA loan, right, or something. So at least there will be 2 to 4 occasions where you need to borrow. But when you borrow, then uh, it's just the fact that you will have to make payment. You'll need to pay back starting the next month, right? In monthly installments. So think about it. If you're paying back in monthly installments, that's exactly present value of annuities, right? Because you will be paying back like this at the end of every month. Okay, so let's think about um, how we can solve that equation. First, let's go to let's solve the problem. Uh, row 17. If you go to row 17, do you have this file in front of you? Do you all have this file in front of you, everyone? Hmm?
Yes.
Okay, at least 2 people, Tia and Claudia, have these files in front of them. What about the rest of the class? Do you have this file in front of you? Hmm? Kelly, your microphone was on.
Yeah.
Alicia, you have it in front of you. Okay, at least three
Yeah.
people confirmed. Kelly, four confirmed. Okay, so I think I have um, 4 good people, right? 4 good students. So this is exactly that example. If you choose annuities, right? You receive 20. Let's say you receive $20,000 um, every month. It's going to be 30 years, and currently the prevailing market rate is 6%, going rate in the market 6%. But we know because it is monthly payment, we are dealing with a compounding frequency of 12. It's a monthly, problem, right? Monthly payment problem, right? So we need to find the monthly rate, which is, nothing new. We already know this. And actual number of payments or compounding is 360. Right? And then using, I don't know what, okay, using this formula, right? Simply we're gonna, so payment over R minus payment over R times 1 plus R raised to N, close parenthesis, okay, and hit enter. I'll show you what I did, what I put in there. But don't try to copy A17 E17, right? Don't do that. Um, Try to enter this formula there, right? You need to be able to. You should be able to. Basically, it's a coding. It's a mathematical algebraic. It's an algebraic coding, right? You should be able to code it. Um, Once the formula is given, right? All you need to do is do exactly like that. But here, the conclusion is, oh well, the present value of all those annuities are only 3.335 million. 3.335, which is what? Which is what? What are we trying to do now? We're trying to find, isn't? Aren't we trying to find if the present value of those annuities are greater than the 6 million or less than the 6 million, right? Isn't that what we're trying to find? And what happened? So what did we find? Actually, the present value of annuities are less than, right? Let's see. I think that's the only color and there's nothing. Okay. Nothing brighter, nothing brighter or nothing, thicker than this yellow. So then we find our we can easily get to our conclusion. The conclusion is, oh, the present value of the annuity is less than the lump sum. Then in this case, we should choose lump sum, right? But again, it's present value. In other words, it's discounting. So the present value depends a lot on what the interest rate is, right? If interest rate is higher, then it gets discounted more, it gets discounted deeper. And if the discount rate is lower, it gets discounted less. So 6% interest rate is something that's nowhere near any reality these days, right? These days, the actual interest rate is at best, 1%. It's not even 1%. So if we use 1% interest rate, and if I drag it down, oh, then what do you see? The present value of annuities are greater than 6 million. Then, in the age of low interest rates like now, right? Like these days, since 2008, annuity is a better option, right? Because the present value of those annuities would be greater than 6 million. Okay, so this is one thing we can, and this is actually the second example. Okay, the second example, actually second. What was the second example? Car financing, right? So you consider financing a 30,000. You're considering to buy a car, and the price of the car is 30K, but you want to finance it, right? For 5 years with 20% down payment. So then if you make 20% down payment, which is $6,000, then the amount borrowed will be 24K. And if that's the case, what is the correct, two questions, what's the correct payment? Or if the dealership says that your monthly payment is 500, is this a good deal or bad deal, right? So We have run out of time already. We are running out of time. We haven't yet. So I don't think we can do it today. Um, but this is already, this is an ongoing. I wouldn't say this is an ongoing. I mean, but in your mind, because uh, you just finished midterm, and these are midterm questions exactly, right? Uh, so in your mind, this is an ongoing struggle, right? I believe, did I get it right? Did I get it right? Uh, how do I solve that problem? Um, but there were, some problems like this, so it will be sort of like a review. Uh, uh, Now, there were 40 problems in the midterm, and these 40 problems were pulled uh, from the big uh, question pool, right? Uh, of like hundreds of problems. So um, these 40 for each individuals, right? Um, for each individual student, the set of 40 problems, the set of 40 problems may be all different, or some people may have similar problems, but at least the numbers are all different. In other words, the input data are all different, and they are in random order. Someone probably opened an exam with already hard questions up front, and then later towards the end of the exam, easier questions. Or some people may have started out with easier problems, and as the exam, as they reach the end of the exam, the problems progressed into more difficult ones. So it was all in random. The order of the questions were all in random. But I look, although the due date is over, but I still accept late submittals at 10% late penalty per day late. So if there are people still working on it, you better do it ASAP, because after 10 days, even if you get 100, it's going to be zero, right? And I have posted, but it's not available yet. I have posted um, in the no, not course information, but in course materials. Uh, in that folder, I have posted this file, but it's not going to be available yet because some people are still working on it. So uh, this will be available from after April 11th, which is next Monday. Um, so some people might think, oh, if I don't submit it, if I hold on to it until 11th, and then this file is available, then maybe I can. Well, once again, by then you will be 7 days or 8 days late, right? You will be 8 days late, and then it's like you will be losing 80% anyway, even if you get 100. Besides, uh, the order of the problem is not the same. It's all at random, and input data are random. You have to really look hard into this file to see which one is the matching your number 3, because everyone gets all scrambled, right? Everyone gets the questions all in scrambled order, and the one I did was also in scrambled order and would be completely in different order from any one of you. So you have to really look closely. You have to even when this is available, right? You have to look very closely uh, to match it with the problem that you had difficulty with. So again, it is there, and it's going to be from April 11th. Okay. Alrighty, that's it for today. Uh, uh, any questions? Any questions so far? Any questions? If even if you have questions, I can't take it. I can't take it now because, as you know, I have another class starting at.
No, I have one question, like for 20 seconds, please.
Yeah, 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 yeah. Okay, but let me dismiss the class first. So, uh, have a great day, everyone. And if you have a short question, you can stick around. But I'll try to answer your questions. Okay, only if it is a short question. Otherwise, send me an email, please. Send me an email. Okay. Alrighty. So I'll stop recording, but I will stick around. I won't sign out until. Alrighty. Stop recording. Have a great day, everyone.